Thank you very much, Alison. And hopefully you can. And hopefully you can now see my slide.
Yes.
Great, thank you. So thank you very much for inviting me to talk tonight. That's very much appreciated. My name is Paul Dodds from University College London, and I'm talking about the very small topic of the role of hydrogen and fuel cells in the global energy system. So in 20 minutes, I can do a little more than just scratch the surface, but if you have any more general questions, I can normally field some questions on quite a few topics. So we'll if there's anything I don't cover, then by all means do ask in the Q&A session. I'm sure between the three of us, we'll be able to come up with something interesting. And so I'm going to start off my story about 200 years ago on this cartoon you can see in the background here, which is a peep at the gas lights in Pall Mall. And this was really the time when hydrogen first made an entry into our energy system and had a huge impact on our society. In 1812, hydrogen became mainstream as part of the Gas, Light and Coal Company, which was incorporated to provide lighting. And that was hydrogen in the form of town gas. Town gas is about 50% hydrogen, plus some carbon monoxide, some carbon dioxide, and some methane, and a few other bits of nasty bits and pieces. Why did they use town gas for lighting? Well, first of all, there was an economic case for it. It was about a third of the price of whale oil. And secondly, it provided a better quality of service than whale oil. It provided a brighter and safer flame. And from having the first company incorporated in 1812, there was widespread adoption of street lighting in towns and cities throughout the UK by 1820. And from about 1875, it was used for cooking as well. And it caused a social revolution. The reason was because it was light at night, it was much safer to go out in towns and cities than it was previously. And so it actually caused a revolution in how we lived our lives in a way that's rarely been seen since for energy technologies. And then, of course, we had natural gas was discovered in the North Sea in 1959. And pretty quickly, it was decided to convert the whole country to use natural gas instead of town gas. So the conversion program started in 1967. It was completed in only 10 years, 1977. But there was quite a change in how we used gas. So until then, we'd used gas for lighting and then heating. But once we had natural gas, because it was so much cheaper, we started using it for heating. We previously would used it for cooking, but we started using it for heating instead. And so you can see on this graph on the bottom left how our use per customer increased rapidly when we converted to natural gas and everybody fit central heating to their houses. So the role of gas has changed, but hydrogen at that point dropped out of our energy system. And the question is whether we're going to return to using hydrogen in the future, whether that's for cars, which has been the area that's had the main hype in the last 20 odd years, or for heating in the bottom left, and that's actually the area where hydrogen and fuel cells are mainly used at the moment, or perhaps for industry and other areas. So as I say, for the last 20 years, most of the hype about hydrogen and fuel cells has been on cars. And there's been various designs made. And the difference in the key step in the last few years is that you can actually go out and get a hydrogen car now. And that's only happened in the last 3 or 4 years. They're all East Asian cars, Hyundai or Toyota. But they are actually being commercially produced. Still at a very, very small scale, but they're coming off an assembly line as opposed to being custom built, which greatly reduces the cost. And that's really a key step for getting the cars into the market. At the same time, though, there's an awful lot of battery cars that have become available in the last few years, far more than hydrogen cars. And there's a lot of hybrids and such like on the market. And so there's a big question mark about whether fuel cell cars will actually have a major role in the future. Some countries think yes, other countries think no. The UK is more in the no camp. But there's a number of other markets for fuel cells that are receiving a lot more attention. So in the top left, we have forklift trucks, where fuel cells are actually quite widespread in the United States in particular. And that's because they give a better quality of service than battery forklifts. They're much faster to refuel, and you can't use internal combustion engines in warehouses because of the emissions. So there's been a switch towards fuel cell vehicles from battery vehicles in the USA. Other markets we're looking at are very much heavy-duty vehicles, so buses and trucks, and you're going to hear some talk about that a bit later, and trains. And the first trains are now being built. We've seen buses in Aberdeen. There's been buses in London for a few years, and buses are being deployed in a few other cities as well, as demonstration projects. The government's now actually committed to building the first hydrogen bus city town in the UK to go alongside the first electric bus town. So they are certainly being tested, and the feedback I've had from Transport for London is that they really like them. They think they're very good and they're very reliable. In fact, they've had a lot less problems than they had with the battery buses that they were running at the time. Now, when we think about any technology, we can think about a hype cycle, and this is called the Gartner hype cycle. So it starts off with a technology trigger at the left-hand side, and once the technology starts to be developed, it tends to start to become very visible. So it gets a lot of hype when we get to something called the peak of inflated expectations, where people expect an awful lot of the technology. But the trouble is the technology at this point is still in the early stages of development. It's not in a condition that it would work well in a market, and it's not at a price that people would be affordable in a market. And so what normally happens is that people get to a very high peak of inflated expectations, and then nothing happens, and then suddenly the visibility drops down into a trough of disillusionment. Okay, and people say, "Do you remember that hydrogen thing? It came around 20 years ago. Hydrogen fuel cells. It's disappeared now. I wonder what happened to it. It just turned out to be a waste of time." Except in those last 20 years, people had been quietly developing the technology in the background, cutting costs, overcoming technical barriers and such like. And actually, by the time you hit the trough of disillusionment, it's almost at the point where it's approaching commercial maturity. And so you start going up the slope of enlightenment, and eventually you hit a plateau of productivity where you've got a bit less visibility than you had before, but this time it actually works and people start selling it and start using it. And so if you ask where are we for hydrogen at the moment, I'd say that we're somewhere on the slope of enlightenment. We had the peak of inflated expectations around 2002, and we've come down a lot since then. And it's not uncommon actually for new technologies to have a 20-year development cycle, even in places like Silicon Valley, where you might expect that new products to come out very quickly. That's pretty common to be a 20-year development. So why do I think we're somewhere on the slope of enlightenment? Well, first of all, because there's been a move from basic research on hydrogen and fuel cells to actually developing hydrogen fuel cell products. And you can see this by looking at the number of patents that are being granted in the areas. So the graph at the top shows the number of patents for fuel cells. And there has been a shift over time from a focus on fuel cell design towards integrating hydrogen and fuel cells into transport and other products. And you see that on the bottom, how you see a peak in more recent years. Now, if you're probably looking for the UK on this graph, and you'll see it's one of the very low ones at the bottom. Japan and the USA, and more recently Korea, are very much the leader in patents in this area at the moment, and have the fastest industries. Hence why the cars that we saw earlier are Japanese and Korean. Another reason I think we're going up the slope of enlightenment is that large industrial players are really now starting to get involved, advocating hydrogen solutions to decarbonisation problems. So, for example, we've had the Hydrogen Council being formed, which has a large number of very influential companies and very large multinational companies involved. And they're really pushing hydrogen solutions in a lot of international forums. And that's really having an impact. So governments are becoming very interested at the same time in hydrogen. Large companies are starting to put some money into development, and that means we should start seeing it actually being used going forward. Thirdly, because energy transition studies suggest that hydrogen is likely to have a major role in the future. Now, most people, when I'm talking, ask me if we should electrify or if we should use hydrogen instead. Now, in reality, in some ways, hydrogen will compete with electrification, but in other ways, it will complement electrification. For example, through power to gas for excess renewable generation. It does a bit of both. And it's very hard at the moment to work out exactly what the optimum amount of hydrogen might be in the system. So here, for example, is three scenarios from a report we published last year on hydrogen innovation for the UK. So these aren't global scenarios, these are UK scenarios. And in one scenario, we had about 3 megatons per year of hydrogen being used in 2050, primarily in industry. And a second one where we were using flexible technologies. So for example, plug-in hybrid hydrogen cars or hybrid fuel cells, which have a hydrogen boiler and hybrid heat pumps, which have a hydrogen boiler and an electrically powered heat pump together in order to provide flexibility to the energy system. Then we had about 88 megatons. And if we decided just to use hydrogen for everything, then we get about 19 megatons. So what we learned from this is that there's a wide range of potential uses of hydrogen. I should say we currently have about 0.7 megatons of hydrogen used in industry in the UK. So we have a substantial amount, but it's all in industry. And we can certainly see that there's going to be a role in industry going forward, but it's harder to see that in other sectors. We think there's likely to be a role. The fourth reason why it's up the slope of enlightenment is it's not clear to me whether fuel cell or battery vehicles will be cheaper in the long term. So this is a projection we did a few years ago, but I think it's still right, where we tried to work out what the cheapest technology would be going forwards. And you have a range of technology. So BEV is a battery electric vehicle, FCEV is a fuel cell electric vehicle using hydrogen, and FCFEV is a fuel cell plug-in hybrid electric vehicle. So using a bit of electricity for half of its miles and hydrogen for the other half of its miles. Okay, and what we found was that the costs lie somewhere around £50,000 to £60,000 as the total cost of car ownership. So that's including buying the car, keeping it operating on the road, including insurance and such like, and fuel costs. Okay, what we found is the costs are fairly similar, about 50,000 to 60,000 once you get beyond 2030 for all of these types. And my conclusion from this graph is that I have no idea what would be the cheapest system going forwards. The uncertainty bars are much larger than the differences between the various technologies. And so it might depend on what the quality of service each type of vehicle can provide, and that might depend on new technologies coming through. So for example, if we had a breakthrough in batteries to use lithium-air batteries, which provided a much greater energy density, then that would really help battery vehicles. Although all fuel cell vehicles in practice have batteries in them too. They're all at least hybrids, if not plug-in hybrids. Another thing that would help battery vehicles would be super fast charging in a way that is readily available, has the infrastructure available, and doesn't damage the batteries. And so when you talk about range and when you talk about refueling, you have to take into account the quality of the service as well as just the cost. But it's possible in the future we might buy different types of vehicles for different uses. So for example, a small car that you're going to use as your second car, mainly in the town or city, might be battery only. But if you want a car for long distance travel or a large family car, then you might use a hydrogen plug-in hybrid or a hydrogen hybrid car. So you might have different types of cars sitting on your drive, rather than everybody using a petrol/diesel internal combustion engine like we do at the moment. Now, one thing you have to ask yourself when we look at the previous graph assumes that we put lots of money into developing battery vehicles, and we put lots of money into developing fuel cell vehicles. So you have to ask yourself whether that's reasonable, and have battery vehicles already cornered the market? So this is vehicle sales. I think it's up to about February this year. So it doesn't, 2020, 2021 doesn't quite cover the whole time horizon. And what you can see is that we have mainly been buying internal combustion engine, ICE cars, over the last few years, despite the availability of alternatively fueled vehicles, as they're called. But we've gradually been increasing the proportion of alternatively fueled vehicles. So in the last year, actually about 20% of all vehicles were not your traditional internal combustion engine vehicles. And if we zoom in on that little bit there, then this graph shows you what they were. And if you ask me in sort of about a year ago, say, certainly maybe 2 years ago, if you'd asked me, are battery vehicles taking over the market, I'd have resoundingly said no. Because if we look at the 2018, 2019 numbers, the number of battery vehicles is very, very low. Really, really low. You know, there's a few thousand there. and most alternatively fueled vehicles are hybrids and a few plug-in hybrids. However, what we've seen in the last couple of years is batteries are really starting to take off. And so 8% maybe of all cars in the last year were battery vehicles, and almost 20% were alternatively fueled vehicles, so had a hybrid or plug-in hybrid. So we can really start to see alternatively fueled vehicles taking off now, and maybe batteries are starting to corner the market. Hard to tell. The other thing we need to worry about is innovation funding. So would that innovation funding actually be made in order to bring down the cost of fuel cell vehicles in a way that would make them competitive with battery vehicles in the first place? Because otherwise, the graph I showed you earlier comparing the costs isn't valid anymore. It assumes that those investments are made. And innovation works. So here's some graphs for heating in Japan, heating systems. So these are micro CHP, combined heating and power systems that are installed in Japanese homes. And we have several 100,000 fuel cells already installed in Japanese homes. It's by far the biggest market for fuel cells globally. And the graph on the left-hand side shows the price per system and how it's reduced over time as the number of systems that's been deployed has increased. It's a logarithmic graph, so I do note that, at least on the cumulative installations, but it's a very typical example of an innovation curve where we see the costs coming down through learning by doing as we deploy technologies, and we'd expect something similar to happen for hydrogen vehicles and other hydrogen fuel cell technologies going forwards. The final thing that we need in order to make hydrogen work is infrastructure. So, if you can't refuel your car, you're not going to buy the car in the first place. And there has been some studies done. An H2 mobility study a few years ago concluded that with about 60 small refueling stations, you could cover about 80 to 90% of the population of the UK. And if you considered it was about £1 million per fueling station each, that's £60 million, which is not a small amount, but in terms of energy investments for the UK, it's not large either. I mean, it's something that we could afford if we wanted to do it. In the longer term, we'd expect to have lots of pipelines going around the UK, and that would make the cost of delivering hydrogen much lower. And this is an example from the model, from a model study. What this model doesn't take into account, though, is the cost of managing investment risk. So what happens if I build all this infrastructure and the demand for hydrogen doesn't materialize and everybody just uses battery vehicles? And that's something that we really need to think about how to get around. So I've talked a little bit about infrastructure, I've talked about vehicles, and I've talked a little bit about heating. We can partially decarbonize the gas supply by injecting hydrogen into it. And so one way that we've been considering supporting renewables or a greater proportion of renewables in the system is through power to gas. So when we have times of excess renewable generation, we convert that electricity into hydrogen. And then if we don't have any better use for it, such as putting it at a refueling station, then we bung it into the gas networks. At the minute, you're not allowed to do that. In the UK, the current hydrogen limit is very low because it's based on gas regulations set in the 1960s, which are essentially designed for the quality of North Sea gas. In reality, you can put a lot more than 1% in the system, but we're not really sure exactly how much you can put in, and that's being tested at the moment. So there was a project at Keele University to put 20% hydrogen into the system, but that was quite a closed system. Now, what we find is we're pretty sure you could get 3% hydrogen by volume. You could probably get 6%, quite possibly get 10%, but it would be pretty challenging to get to 20%. You could do it for boilers and standard things, but it's all of the non-standard gas appliances that in many cases we didn't really realize still existed that are likely to fall over and have potentially safety issues, or at least at the very best will stop working. There's other issues too. So for example, if you're burning hydrogen, the flame temperature tends to be a bit hotter and you might burn out the back plate of your boiler a bit more quickly. If you have a 10-year warranty on your boiler, then that might invalidate the warranty, and then somebody's got to pick up the bill for that, and we don't really know how that would work. Would it be the gas company, the government? Would that be your problem? So that's something there's some technical issues that we still need to sort out, I think. it would be economically viable to do it, but gas is very cheap, and so it's kind of a bit of a waste of very high quality hydrogen put into the gas networks compared to, for example, using it for transport. We have looked at hydrogen for heating in the UK, and that's something that's received a lot of attention in recent years. Started off with the Leeds City Gate H21 report, which looked at converting the city of Leeds to use Leeds hydrogen. And the good thing about it is it's a business as usual option for homeowners who have natural gas heating. You have a boiler, it works exactly the same as a natural gas boiler. It's high power, it provides the same water temperature for hot water and for heating. It just doesn't produce carbon emissions. In contrast, if you want to use some sort of a heat pump, for example, you tend to really change your whole system, and that's quite important. So that quality of service issue, again, that we talked about right from the start with town gas and lighting, that still comes in for heating too. We think a lot more about the economics and carbon emissions when we work out what sort of heating system we want. There's a lot of interest at the moment at using hydrogen in industry. So one question is whether we can decarbonize high temperature processes using hydrogen, because they can be quite difficult to do using electricity. There's a lot of interest in using hydrogen as an alternative to produce steel, for example, in Midrex steel production plants. Now, this kind of isn't a new thing. So there's about 100 Midrex plants operating around the world that currently use natural gas, and that natural gas is reformed into hydrogen within the plant and then used to reduce the iron ore into iron. Now, I don't think it would be a big technical step to just feed hydrogen directly into that plant and then not have any of those carbon emissions. And that's something that people are looking at within the UK. I think from what I've heard, there's a lot more interest in using hydrogen than there is in trying to build CCS into steel plants, carbon capture and storage. Another advantage of converting industry to use hydrogen is that you suddenly get a high demand at a single location, and that gets around your investment risk. So, if I'm somebody who wants to go out and build a hydrogen plant, I'm pretty sure I'm going to have a high demand that's going to continue, and I can build low demand. I can build additional low demand infrastructure on top of that. So, for example, for refueling stations nearby. And it would also allow me to build lower cost hydrogen infrastructure to deliver that hydrogen. And so the UK is currently looking at using hydrogen in several large industrial clusters. There's huge knowledge gaps, and I think it's fair to say that worldwide, this is something that's only just, people are just starting to kind of become aware of the potential in hydrogen. The UK is probably a little bit ahead of many other countries in terms of using hydrogen in industry, or at least considering the possibilities. Another area, and I think the final one I'm going to talk about, is synthetic fuels, which is even further behind. So this really is kind of on the drawing board almost, where we're starting to think about how we can continue to fly sustainably, to a lesser extent for using fuel for shipping, international shipping, because for shipping you can use ammonia. And there's a good chance that in future we'll be trading hydrogen in the form of ammonia internationally. There's already routes being set up from Australia to Japan and from Saudi Arabia to Europe, where they're going to produce hydrogen using renewables and then convert that into ammonia and then ship it as ammonia. And looking forwards, we could actually start to use synthetic fuels made from hydrogen and captured CO2 for aviation. We've put that into our models quite recently. We found that it's by far the lowest cost method of decarbonizing aviation. And if you want to go for a net zero target, it's something that you really should be considering doing. So it's something that industry is also starting to get involved in. So for example, BP and Johnson Matthey are trying to design a plant to produce hydrogen, to produce jet fuel from hydrogen and captured CO2. So this is something that is becoming on the horizon, but could become quite a big demand for hydrogen in the future. Yeah, here is a graph actually showing this is what in the graph on the left hand side. This shows what happens when we don't have these synthetic options to produce fuels, where basically we continue using oil for aviation in the long term, and we offset those emissions using biomass with CCS or something else like that. If we let the model have the choice of using these synthetic fuels, then it will use them, and we don't have any more oil in the system. So it's a huge change. So with all of that, I'm going to conclude there because I'm pretty sure my 20 minutes must be up. So 3 major points. Hydrogen cars powered by fuel cells are belatedly being commercialized, and a range of other hydrogen technologies are also being pursued. I think the sector has a lot more realism than it had in the past. Economics is a key driver. I think user experience, the quality of service, is absolutely going to be a key driver, and one that's had less focus in recent years. The third one, which I think is moving up the agenda, is air pollution. So now that we have affordable cars which don't produce the same air pollution as internal combustion engines, I don't think it's going to be very long before you'll start to have quite a lot of restrictions about driving into urban areas with an internal combustion engine vehicle. So I think that will be a key driver for battery vehicles and for fuel cell vehicles in the future. Finally, I think the future for hydrogen is very difficult to predict, not least because it can contribute in so many diverse ways across so many sectors, spanning the whole energy system. So I can try and make predictions, or forecasts, but I would take them all with a pinch of salt. So thank you very much for listening. Please do contact me if you have any questions or after this, but I'll be very happy to answer any questions you have today when we get to that section.